We're going to look at section 12.3, and this will be the final section that you do in chapter 12. So we're going to look at just 3 problems in this chapter or in this section and see how they're kind of different from the previous sections. So if a state issued license plates using the scheme of 2 letters followed by 3 digits, how many plates could it issue? Okay, so I just kind of gave you an example here of a license plate. So you have 2 different letters followed by 3 digits. They want to know how many different plates you can get. So we actually you have 5 different places here. And now in each place, what I want to do is I want to consider how many different options do I have for each place. I'm going to look at just the first blank. Now the first blank has to be a letter. So how many letters are there in the alphabet that you can choose from? There are 26 letters. So that means for this first letter, you have 26 different ways. That's 26 different letters that can be in that first one. Similarly, in the second one, you also have 26. Now, the reason you don't have to worry about things repeating here, because I mean, this could be a double, like it could be a LL 1, 2, 3. Okay, so you have all 26 letters to choose from as well here. Now, when you're looking at these 3 blanks, it says that they're followed by 3 digits. Digits are numbers, but these are the digits you can choose from. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many digits total can you choose from? So in this blank right here, it could be any of these 10-digit numbers. So any of these 10 numbers. So there's 10 there, and then there's going to be 10 in both of these places as well. Now, to get your final answer, these are all independent choices. And you've heard me say several times that if you have independent situations, then you multiply all of those together. So you're actually going to take 26 times 26 times 10 times 10 times 10, and you're going to get a big number. The big number is 676,000. And that's your answer. There's 676,000 different license plate combinations. Okay. So let's look at another one. Now let's say you have a restaurant, and on the menu, they give you a choice of 7 different main courses, 4 different desserts, and 5 beverages. So you can choose. So the question is, how many ways can someone order a meal consisting of 1 choice from each category? So you pick one of these main courses, 1 dessert, 1 beverage, and they want to know how many different ways can that happen. So let's look at our 3 different choices here. We have the main course, dessert, and beverage. Now, just looking at the main course, how many different options can be in this blank? Well, you have 7 choices. So there are 7 different options to choose from there. Dessert, you have 4 choices, and beverages, you have 5 choices. Again, these are all independent of each other. So to get the total answer to this, you would multiply these together. So you would have 7 times 4 times 5, and you would get 140. All right, so that's your answer. Okay, we're going to look at one last problem, and then we're going to call it quits. This problem is not necessarily that hard. The hardest part is making sure that you type it correctly into WebAssign. So consider selecting 3 elements. The elements that you are going to select are A, B, and C. And it's coming from this set. This big set A is the set A, B, C, D, and E. Okay, but we're only going to pick A, B, and C. It says list all possible subsets of A that use all 3 elements A, B, and C. Now, they may sound confusing, but it's really not quite that hard. In WebAssign, you're going to get this box to type your answer in. Now, they will tell you to make sure that you use the roster method. So if you go back a few chapters when we talked about sets, you're going to remember that this right here is like the roster method. So if you think about it, you have in roster method, you have to have the curly brackets. And they want to know how many different subsets can you have. They want to know what is the subset. Okay, list all the possible subsets that contain A, B, and C. Well, this is your answer. It's just that one subset that has A, B, and C. And the reason why is that the order doesn't matter here. So you could have BAC or CAB, whatever. It could be in any type of arrangement, and it's still the same set. All right. So when they talk about listing a subset, that's what the subset is. Now there's a second part to this question. Now they ask you to list all possible arrangements of these 3 elements. Now this is where order matters. And when it will also tell you to type your answer as a comma separated list. So let me help you with that. So this is actually your answer. And let me show you, you would type in the first one in parentheses, A, comma, B, comma, C. When you close your parentheses, you're going to type another comma, and then you're going to type in the next arrangement. So if I started with A, I'm going to start with A again. And instead of saying ABC, I'm going to say ACB. I'm just going to swap those around. Then you're going to put another comma, parentheses. I'm going to start with B now. So you have BAC and BCA. Another comma here. And now I'm going to start with C, CAB and CBA. Notice on the arrangements, I don't have these curly brackets. I just have each of these little elements, excuse me, each of these elements separated by commas. This is how it has to be typed in. If you don't type it in this way, you get the answer wrong, even if you have all of these elements in here correct. And I know that's crazy, but it's just part of it. Okay, that's all we're going to go over on section 12.3, because I think that you'll be able to complete all of the others on your own. Again, if you have any questions or problems, please let me know. Thank you so much.